All right, so let's continue. So from the values, as I said, you want to take a range. So this guy right here would be 0. This guy right here would be 0. And we go up to 1. As we initially said, we go up to 1. We start at 0 and we go down to 1. We start at 0 and we go down to about 4.5 or 4.25. Right? This is the highest value. So we start at 0 and we go down to 1, and go start from 0 and go down to 4.25. So you want to look at a range of values and then come up with a scale that is easy for you to make your points, right? So we have 0 and this right here, right? Remember we spoke about this in class. Remember this guy right here?
Yes,
Anybody
sir.
remember this? What's happening here? We
We're
cut the
coming
graph,
with.
right?
Mm.
Yes, we cut the graph because the values down here are not there are no values down here. So we can cut the graph and we can bring down the scale, kind of push it down together. Push it together so that we get more space to work with, right? As I said, this is a skill that you will learn over time. And I encourage you can watch additional videos on this, but I'm going to do my part and teach you how to actually write your scale or make your scale. So if we started here, and it is recommended that you use at least 75% of your graph. When you're doing any type of graph, you must use at least 75%, majority of your graph.
Sir, so we not
75%. Go ahead.
we not have something have this have an extra space. We can't start from the zero same way.
Yeah, you can start from the 0, but it will be a little more difficult because you'd have to go 0.1, 0.1,
Yeah.
0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 8, 9, 1. So this will be 0.1. This is not really 75% of a graph, right? This is about 50 or 60%, right? But you can still do that. You can still do it, but it's recommended that you use at least 75%. And you might lose, you will lose marks if if you don't use majority of a graph. If your value stop right here in the middle, right, you lose marks. So you have to, yeah, it can condense your graph, condense down here, so you start at 0.3. Remember, we started at 0.3 here, right? 0.35. So we say, okay, we start at 0.3 and then no, we can go down to 1. Understand? If you have any questions, let me know, please. Want me to go through it again?
Continue.
All
You
right.
continue.
All right. So we do the same for here. Our values range from 0 to 4.25, right? In this area, the last value is here. All right. No, so we say 0 point, we say 0, then this would be 1. So 1, 2, 3, 4. This would be 1. 1, 2, 3, 4. This would be 2, 3, 4. Right? See, stretch your values. You want to have like 2 in between the values, or you can have 4 in between the ranges. Go ahead. All right. So we went ahead now.
So you're saying we can use 2 spaces or 4 spaces, sir?
Yeah, I don't recommend to use 3 spaces, right? Because it's going to be hard for you to actually plot the values. So use 4 or 2. You can cut a graph if you need to cut a graph. If you need to make your life easy, cut your graph. I'm not stopping you, right? Some teachers will tell you not to cut a graph, but I am totally okay with it. All right. So our values then, right? Let's just run through this quickly in the calculation of the gradient. This is a little tricky part. So remember, our gradient m is equal to, but remember, y2
Off.
minus y1 over x2
X2 take away X1.
x1, right? So let's go back to your notes when you have the time, right? So this formula is in your notes. Everything here is in your notes. So y2, so we draw our line right here, right? We put our line right here in the middle. You want to use in between the first 2 points and the last 2 points because you want to get a good range of values. So when you're doing a gradient, you go between here, the last 2 points and your first 2 points. This is close, right? Close to the other one, but it's good because you want to make it as easy as possible. So you want to use it like a line like this. This line where you know the actual values. This line where actually know the values. So you make it easier, right? So this we're using this guy right here, and x2 right here is 4, right? X2 is 4, and x1 is this is 1.5. So this of course will be 1.75, right? Make sense? This is 1.5, and the middle of 1.5 and 2.5 is 1.75. So we have
There's a
that here.
2.5, sir.
No, two. Sorry about that. Then we have 1 here, and we have 2. In the middle of that is 1.5, right? And in the middle of 1.5 and 2 is 1.75. You understand that?
Yeah.
All right, and we do the same for down here. Question? All right. So this is our x2, this is our y2, 4, and our x2 is 1.75. And our y1, sorry, so x2 y2 is 4, y1 is 1.75. See there? So let's just write that down quickly. 4 minus 1.75. Then now our x2 is right here is when coming down, it is in the middle of 0.9 and 1. So what would that be?
0.95.
Right,
0.8.
0.95. So our x2 will be 0.95, and our x1, what would be our x1?
0.4.
0.4. So I'm just going to run through this as quick as possible because we don't have much more time. 0.4, right? You have any questions? Let me know. Send it in the chat.
Yes, sir. Yes,
Go
sir.
ahead.
Can you go back to the graphs?
The graph. All right.
Sir, the line that you marked, sir, fine, X1, Y2, sir.
Right.
It's supposed to be near to the first point
It's supposed
and
to
the
be
last
in between. In
first
between.
point and first and second point.
Yeah, it's supposed to be in between these, and the last one should be in between these. This will be 2. So this will be 1, and this will be 2.
So the closest boxes, the closest boxes to the first point. You should make the line, sir.
Yeah. So yeah, you finish?
Yeah, finish.
Right. So the boxes here, right, is stemming from this point that I actually highlighted in the middle of 1. So you just want to take an arbitrary point in between. It doesn't have to be in the exact middle right here. It just has to be in between this value here and this guy here.
One box away.
Be the closest, sir.
Yeah, basically. All right.
Yeah.
All right. So
The reason I asked you, I was asking, what did you put it at 2 point?
repeat that.
I was asking, why didn't you put it at 2.00?
2.00. It could also go there. It could also go there, right? But I felt it's up to you. But it's just best recommended to put it in the middle. It definitely can't put it up here. It has to be in the middle of the first two and the first. So it could definitely go here, right? It could,
Oh my God.
right? It could definitely go here. All right.
Okay, sir.
All right. So we finish.
So a different answer, same answer again.
I'm just saying go ask me.
yeah,
A
you would
different answer.
get a similar answer.
But it still
The
will
thing
be
is,
correct.
the more you stretch out your point, the more you have the more space you have between, the closer you are to finding that it's more accurate, right? So if you have a gradient say here, you calculate the gradient from here and here. This is a y2 and a y1. It's not going to be as accurate at these guys as these guys down here, right?
Yes, sir.
So if it's closer, it's not accurate. It's not accurate at all because it's not getting the range of values. So the wider it is, the more accurate it is. All right, make sense?
So one more question, sir. Why to start from the bottom y-axis? The
No,
bottom part of
it depends on
part one?
which value is the the last value that you plotted. So if the last value that you plotted is 4.25, this guy right here,
Y2.
4.25, this would be your y2 up here. Up here would be a y2 in this area, and then down here would be a y1. So basically, for uptrend values that are going up, your values, your y2 values will be at the top. All right,
Yes, sir.
all right. Let's move on. So we're almost finished with our gradient. So 4.4 minus 1.25 here is 2.25, right? And then 0.95 minus 0.1 would be 0.5, right? You can do these calculations afterwards. And then our 2.25 divided by 0.5.
Hey, one more.
Go ahead.
0.4.
0.55.
0.55, yeah.
Oh, because of 4. Oh,
All right. And then our final answer would be 4.09. So this would be our gradient, right? Our gradient m equal 4.09. Okay, now to the interesting part, we have this formula right here. Mr. Treasure gave us this formula to find G, our gravity. What we said G is again?
Gravity.
Yeah, what is the value for gravity? Remember?
Yes, sir. 9.8.
So G
9.8 is
equal 9.8 meter second squared,
seconds
meter per
square.
second squared, right? So
Yes, sir.
interestingly, we did our calculation with our m, right? I got this value, and let's just do it for this should be pi squared, right? Pi squared. There was an error in the presentation, so it should be 4 pi squared over m. I gave you this formula. Our m is 4.09. Remember, m equal 4.09, so we'll just plug in that. Pi squared 4.09, right? Anybody can somebody try and quantify that for me, please? Find the value of that for me, please. You know, 4 times pi squared first, do pi squared first, and then it times it by 4.
square negative 1 is as it never.
Anybody get it or working at it?
So 3.91.
3.91, 4 pi squared.
4 pi.
4 pi squared is how much? All right, do pi squared. How much is the square of pi? Times pi by pi.
What formula again? No, it's 22/7. I don't know.
No, use 22 over, just use 3 3.14. 3.14. Use that one. 3.14.
Sir, at 12.56.
No. 3.14 squared. What is 3.14 squared?
I got 3.07.
No, that's not it. Times 3.14 times 3.14. Right? 3.14 times 3.14. What they get?
So I'm square, me get 1.772.
9.85.
What? Yo, Mike, your mic, bro.
9.85,
Shit.
sir. 9.85.
All right, so 9.85 times
Wait.
times 4 is how much? How much is that?
What?
Hold on.
So when you square,
39.4.
when you square 3.14, you get 1.772.
You
No.
said times it. Just times the 3.14 times 3.14.
That's a square, sir.
Yeah, squared. 3.14 squared is 3.14 times 3.14.
Sir,
Make it different answer,
39.4.
sir.
So where say M equal?
39.4. M equal 4.09.
4.09.
So if we say 3.94 divided by 4.09, which is our M, what do we get now?
16.36.
3.94?
16.36.
You said 3.94 or
No,
3.14?
39.4, sorry. 39.4
6
divided by
pounds.
4.09.
And you get
Sir, 9.63.
9.63. All right. So we see any similarity to this guy up here? Anybody?
Yes, sir.
Right. So this value is 9.63 and this guy up here is 9.8. So it's the same thing. So that means that our calculations were a little off. Well, I did the same calculations and I got 9.86, right? Right, I use the exact calculations as best as possible and I got 9.86. So it's close to 9.8.
So you're saying that the answer is not accurate, sir.
Yes, the 9.63 is not accurate, right? Because we rounded up a lot of values and so forth. But it is good. It is close to 9.8, right?
So I get a mark for that.
Yeah, man, you would get full marks, right? You get full marks. So let's go back to and recap. You can still try and plot the graph. All right, still try and plot the graph. All right, so we're finished here for the day. All the best. We'll meet again next week.
Sorry, look at me. I have to go buy one graph leaf or try look one.
All right then. Try to send it as soon as possible, and we'll try and mark it when I have time.
Yes, sir.
All right. All the best, everyone.